Hi all, let us learn about MCB today. MCB, as the name suggests, a miniature circuit breaker. It is a breaker or interrupting equipment during fault. So MCB comes in different poles, number of poles. This is the picture of MCB. This is single pole MCB. This is two pole MCB. This is again a three pole MCB, and this is four pole MCB. Let us understand the specification of MCB. First is the current rating, and before that, the standards that is followed in MCB is in not only MCB, it is all low voltage circuit breakers. Is one is IEC 60947, and another is BSEN 60898. It is BSEN 60898. So the current ratings are from zero point 0.5 to 63 amperes. So generally, these are the current ratings. Number of poles, as I have already mentioned, that it is single pole, double pole, three pole, or four pole. For in case of DC, it is single pole or double pole. Thermal characteristics, it is also known as time current characteristics, and this is the most important part to understand in any MCB. This can be curve B, curve C, and curve D. These are the most used curves. We will discuss it a little bit later. Now, breaking capacity is 10 kiloampere. This is the short circuit rating. For the DC, it is a 6 kiloampere. I want to mention it here that this specification I have taken from L&T Exora brand. So, for other brands like ABB, Siemens, and maybe Legrand or BCH, the values could be little different. Like this, for the DC, it is 6 ampere. They can have a little different value, but major parameters will remain same, which are as per the specification. They are going to remain same. Now, voltage rating is 240 or 415 volt. It means it can be operated in 240 volt or 415 volt. So based on our requirement, we have to select the model, and for DC it can be 130 volt DC or 250 volt DC. Current limiting class, or this is also called energy limiting class. Most of the manufacturer class 3 energy limiting class or current limiting class MCBs. The meaning of this is that during short circuit, how much lead through energy it will allow. Beyond that, the device get damaged. So there is a table in the BSEN 60898 that defines how much energy is there. I'll show that table later. Frequency 50 hertz to 60 hertz. The device is suitable for the 50 hertz to 60 hertz frequency. The 50 hertz is normally accessible to India, and 60 hertz for many different countries. Some part of UAE, I mean the Middle East, and also US, they operate on 60 hertz. So based on that, we need to select. Rated impulse voltage is 4 kilovolt uh, for this device, and impulse voltage is a voltage profile where the voltage rises very sharp to a peak and then decay to half of the peak voltage. So if that is the profile of the voltage, then we can say it is a impulse voltage. Minimum operating voltage is 24 volt for DC and AC both. As it is mentioned that the rated voltage is 240. Similarly, the minimum operating voltage, that the voltage if goes down beyond 24 volt, then the device will not operate properly. And then degree of protection, it is called IP protection, is ingress protection of the enclosure. I'll create a separate video on ingress protection, but for now, let us understand what is the meaning of 20. The first letter 2 represents the size of the solid particle, and the second letter 0 represents the um, liquid. In most cases, it is water, protection against water. So 2 means a particular size of dust which cannot enter into the enclosure, and the 0 means there is no protection against water or liquid. Termination, there are both side terminations available to connect the MCB with the wires. Connecting torque means at what torque you can connect with the cables in the terminals. This is 6 Newton meter is the standard torque which is required, not more, not less. If you give more torque, then it will damage the terminal, and if you give less torque than that, then there will be loose connection, sparking and all will happen. Permissible ambient temperature, the device operates between minus 5 degrees centigrade to 55 degrees centigrade. This is another important aspect. Whenever we design, we need to check the ambient temperature. That is a very important issue. Many areas where the temperature is below 5 degree, and many areas, particularly within the plant, there are, mm, for example, within the steel plant, there are areas like SMS where the ambient temperature is much higher than 55 degrees centigrade. In that case, we need to go for special devices. One need to keep in mind while designing calibration temperature 30 degrees centigrade. It means that whatever parameters we can see here, this for example the currents, short circuit currents or rated currents. So these values are measured at 30 degrees centigrade, and trip circuit has also been calibrated in 30 degrees centigrade. Now, for example, the device is operated. We have installed the device in an area where the operating ambient voltage is let's say 50 degrees centigrade. It means we need to derate these currents, whatever we can see in this catalog, but truly speaking, for MCB, no one does this, but this derating is very important while using other devices like cables or transformers, HT breakers, etc. Mechanical life, you can operate the mechanical switch in front of the MCB for more than 1 lakh times. Electrical life is how many times it can trip and reset. So for up to 32 ampere, it is 20,000. For up to 32 to 63 ampere, it is 10,000 times, which is really high. Generally, the life of a MCB spans something around 10 to 15 years. And mounting position, it can be mounted horizontally, vertically, flat on the beam rail. This is what I told that I'll tell. Lead through energy. So this is the chart from BSEN standard 60898, which says that in the left side, look at this, left side is 3 kiloampere short circuit capacity and 10 kiloampere short circuit capacity. So in our case, it is a 10 kiloampere short circuit capacity, and let's say the current is this nominal current IN is less than 16 ampere, then lead through energy will be 60 kilojoule. That's how it is defined. But this parameter is really not that important because everyone, almost all the um manufactures the MCB which is of class 3. So nothing to think on it. And this is the profile of an impulse voltage. As I said, it rises, the voltage rises very sharply to a peak within a very small time and then decays to its 50% of value. If this is the profile of a voltage, then it can be defined as a impulse voltage. This is the profile of an lightning impulse voltage which rises to a peak within 1.2 microsecond and goes to the 50% of the peak in 50 microsecond time. That is how a impulse voltage is designed. I mean defined. And now let us understand this curves. These are called uh, TCC means time current characteristics curve. X-axis defines the current and y-axis defines the time. And these are all logarithmic chart. It means uh, it multiplies in tens. For example, this is 0.2, 0.02, then it is zero point 0.2, then it is 2, then it is 20. So these are all equal distance value. Why it is done so? To accommodate a larger value in a short area. Just think of this like the current. The current here is 1, here is 10, the next is supposed to be 100. Uh, Rather than that, if it would have been a simple graph, it's a linear graph. Let us consider a linear graph. This is 1, then somewhere it is 2, then somewhere here it would have been 3, then 4, then 5. We would not have seen even up to 30 ampere current in this area. So to see that larger value, we have made it in a logarithmic scale. I hope you have understood the concept of why we use the logarithmic scale while using these kind of graphs. It is a common practice everywhere in engineering and science to use the logarithmic chart to see the chart in a small area. Now let us understand what it means. Type B. Type B means it's a resistive load. This device is good to use for resistive load. Resistive load means maybe the heaters. Heaters are the resistive load. And type C and type B good for inductive and highly inductive load. Normal inductive load like the your these lighting circuits, for example. Lighting circuit could be an inductive load, but it is not that inductive. Again, high inductive load, maybe the transformer, maybe the motors, these are considered as a high inductive load. What is the difference between the resistive load and the high inductive load is that um, in case of resistive load, the starting current does not shoot, but in case of inductive load, the starting current may be 3 to 4 times. Sometimes it is like for high inductive current, high inductive loads, it goes up to 7 times, 10 times like that. What will happen if I use a class B type of MCB in case of a high inductive load? So let us understand in this curve. So this is the curve for trip curve for this type B, right? So it is supposed to start the tripping mechanism in 3 times of its nominal current. 3 means 3 into IN, right? So since I have connected a transformer in the secondary, the transformer or let's say the motor current will shoot like this and then it will decay. So when it will shoot, it will cross the 3N as well as the 5N, 5N, and this the moment it will cross 3N, the tripping mechanism of the MCB will start and it will trip the circuit. So it means every time you will try to start the motor, it will trip. That is why we cannot use type B in case of a high inductive load, right? So that is the reason why we need to select MCB based on its load and based on its uh, trip time. Now, on the other hand, if we use, let's say, a type D type of MCB in case of a resistive load. So, in case of a resistive load, let's say during starting, uh, it will take only 1.5 times of iron, right? Normally 1 ampere and 1.5 times iron, but I have selected the D, which means it can trip only after 10 times of current flows. So now, let's say there is a short circuit happens, um, and the current is let's say 7 times of the normal current. So current will be somewhere here in this range. Then also, it is not going to be trip. The MCB will not trip because the tripping range of the MCB is much higher than that. So what will happen? The current will continuously flow up to this level, after which the tripping mechanism will get activated. How much time is that? Maybe something 1 second. So 1 second is a much larger time. 1 second is 1000 millisecond. For a breaker, generally it trips in 2 to 3 cycles. 3 cycles means one cycle means 20 millisecond, 3 cycle means 60 millisecond. Rather than 60 millisecond, we are allowing the short circuit current to flow for 1000 millisecond. So by that time, all the damage will be done. Though then using of this breaker is of no use. So selection of the MCB is very important based on its trip circuit. We cannot use type D type of MCB for resistive load. We cannot use B type of MCB for highly inductive load or even inductive load. This is the most important part what I understand in the MCBs, and hope this video was informative to you. Thank you.